Hello, this is Mr. Muller for lesson 4-7, similar polygons. So we're really doing two things today. We're going to decide if polygons are similar, and similar means that they're just the same. So similar polygons are two polygons such that their corresponding angles are congruent and the lengths of the corresponding angles are proportional. So kind of like last time, if we're figuring out if there's a triangle that's a 3, 4, 5, and if there's a triangle that's a 6, 7, 8, are they really the same triangle? And the answer is yes, they are, because one's just blown up to double the size. And that's what we're going to kind of talk about with scale factor. So this is something that architects use, like if they're building a new house, or like when we built a new school. Well, the architects built a smaller model and said the scale factor is, 1 to 10. So that means if you see a hallway that's really a foot long in the model, that means it's really going to be like 10 feet long when they really build it. So this first one is just asking if they're going to be the same kind of triangles. So it's saying that F and G and K and L should have the same proportion. So I have 8 over 6. 6 should be the same. I see H to J is 20 over here. And that should be the same as M to N, which is 15. G to H is 16. L to M is 12. F to J is 12. And K to N is 9. Alright, so if I simplify all these, so that could be simplified by 2, so I would get 4 over 3. That can get simplified by 5, I would get 4 over 3. That can get simplified by 4s, I would get 4 over 3. That can get simplified by 3, and I would get 4 over 3. So these are all going to be, this is going to be a similar polygon, because really this one is just blown up to a 4-3 scale from this one. So they're the same, basically the same trapezoid, except this one's going to be a little bit bigger, but it's all proportional in the same way. Kind of the same thing here. So if I have 8 over 7, is that going to be the same as 12 over 11? And is that going to be the same as 6 over 5? Okay, well, you can see I really can't simplify any of these, and they're not the same. If I can make this, I can't really make this into the same, but let's just compare 12, 11 over 6 over 5. Are they going to be the same? Well, I can multiply the top by 2 to get this to be 12, but if I multiply the bottom by 2, I only get 10. So then really this would only be a 12 over 10 angle, which isn't going to be the same. So this one would not be proportional. Sometimes they're going to ask us to find the missing length. So they're saying, hey, this big triangle or this big trapezoid is 9 to 6, because here's my 9 and here's my 6. Well, what's going to be the length of this smaller side here, my x? And I know that it should be x over 2 then. Well, I can see here from 2 to 6, I'm going to multiply by 3. So from x to 9, I also need to be able to multiply by 3. That is going to be 3 over 2. So 3 over 2 is the same as 9 over 6. So I know this missing x is really going to be 3. Here's another one that's just asking if it's going to be proportional. And this one's kind of upside down, so let's flip it around. So if I'm looking at it the right way, my hypotenuse over here would be 10, which would make this side 6 and this side 8. Alright, so if I'm just looking at hypotenuses, 15 over 10. Now let's look at the bottom, would be 12 over 8. And then if I look at the side, it's going to be 9 over 6. It looks like all of these are going to be proportionate because they're all going to be 3 over 2. 15 over 10 can be 3 over 2 if you divide by 5. 12 over 8 can be 3 over 2 if you divide by 4. Oops, 3 over 2. And then 9 over 6 can be 3 over 2 if you divide by 3. So yes, this would be a case where it is proportional again. Let's find one where we have to find x. So here's one where we would be finding x. So my bottom over here is 20. And that's the same as, or that's proportional to 15. The one I know on the old triangle is 8, or the old quadrilateral is 8. I'm trying to find what x is. Okay, here's one where 8 doesn't go into 20 very nice and even, but I could find out what proportion this would be. So 20 over 15 is the same as 4 over 3. Well, what would that be over here? What would I need to make the x to make it 4 over 3? Well, I would need to make this a 6. Then that would simplify to 4 over 3. Or I can do some cross multiplying. if I figure out 8 times 15 is 120, and I know 20 times x is 20x, divide both sides by 20, I end up figuring out that x equals 6. No matter which way you want to do it, you should get the same answer. And then these are just some more examples of if they are proportional or not. Find another one where we have to find x. All right. So for this one, they give us a whole bunch of extra information. But here's another one where I see that my top is 15. And that should be equal to 10 because there's my 15 and my 10. They're both the top of the, would that be a pentagon? And then I know the left side of the pentagon is 18 2x. And here's another one where I wouldn't be able to find it easily because 15 doesn't go into 18 very nicely. So I would have to cross multiply. So I end up with 15x is the same as 180. I divide both sides by 15. Divide both sides by 15. And I end up with about 12. Okay, and that does make sense. Because now that I see this, 15 over 10 is the same as 3 over 2 if you divide by 5, and 18 over 12 is the same as 3 over 2 if you divide by 6. So make sure that the answers make sense. If I would have got something like 19, well, that doesn't really make sense because this this pentagon is way smaller than this pentagon, so I really shouldn't get a number bigger than 18. So it should make sense on what the proportions are. I also know that this number should have been bigger than 10 because 18 is bigger than 15. So if I would have got a number like 9, well, that doesn't really make sense if this side is smaller than that side. Some of it's going to be a lot of common sense double checking.